Hello guys, welcome to this tutorial. Recursive binary search, okay, which is actually divide and conquer. So in the previous tutorial, we talked about binary search in more detail, okay. So here we're not going to define it again, okay, right? So you should please watch that previous tutorial so that you understand, okay, the concept of binary search, right? So in this tutorial we'll be focusing, okay, more on the recursive aspect, okay, of the binary search, which is actually the divide and conquer, okay, approach. Also the divide and conquer, we talk, okay, we introduced it in the previous tutorial, okay, in this channel. So please, you should also better go and watch that so that you fully understand what we are doing here. So first, the first, okay, approach for this recursive binary, okay, search. So we basically ignore half of elements just, okay, after one comparison. That is the principle. So we ignore half of the elements just after one comparison. That is all. If you understand this, then okay, everything is okay. So we ignore half of elements just after one comparison, okay. That means if you compare and then the element is not maybe okay at the middle and maybe it's less, then we the okay, we ignore the right half. That's the okay approach, and that is all right. It's very simple. So uh, first, and also we compare x with the middle element, okay, as we saw in the iterative method, okay. So if x matches with middle element, we return the mid index, okay, that is the index of that middle element. Else if x is greater than the mid element, okay, then x can only lie in right half subarray after the mid element. So we recur for right half, okay. So and if it's not okay the case, then we recur for the left half. Let's go ahead and okay try to see what is that okay all about, and then we can explain it. Again, please, before you okay jump into this, make sure you have already watched the previous tutorial, okay, so that you understand what is binary search and why is that so important, okay. So now we just include the library, okay. We are not going to explain the concept. This one is just C programming like this, okay. Binary search like this, okay. So we have here, it takes what an array, okay, in parameter, remember from our previous tutorial, okay. In take the okay the low, and then int take the word the age, and then you can just take the x like this, right? So this is okay, that's it. So now we are going to say what if, see the approach now here is different, okay. If age is greater, okay, is greater or equal than L, then do something, okay. Then we declare this our middle, okay. Remember it's pretty much similar to the same one, but here you're going to actually reach the recursion, okay, that is called itself back. That's what recursion is, all right. So we have here okay minus L divided by 2. From our previous tutorial, we should okay, this should be very familiar, okay, to you. So now this is it. So if the element is present, okay, if the element is present at the middle itself, what are we going to do, okay. So if it's the case, if okay, that means what if array of middle, okay, is equal to, sorry, like this, okay, is equal to what, oh sorry, what am I, okay, like this is equals to x, then what are we going to do? It's simple, okay. We just return mid, okay, the index, and that should be all. this is it. Okay, if the element, okay, is at the middle position, that's the best case. Okay, we're also going to talk about time complexity and lower case, okay, best case, worst case, and so on, as okay we move forward in this course, right? Algorithms. Okay, so now if this one is not the case, what are we actually going to do? Okay, we're going to now, if instead that element, okay, array of middle, okay, if array of middle is what is greater than x, okay, you are okay, we agree that if it's greater, that means the element, okay, is it can only be present in the left sub array, right? I hope you okay. That means the element, because this one, remember, is the okay left, okay, sub array. So if that element is less than this middle, okay, element which is this middle, that means the element should be to the left, okay, array of the right. So and then we just do what we return, okay, the search again, binary search. That's where recursion, okay, on array. But now our L is here, okay. If it's to the left, okay, sub array, of course that means we are going to start from 0 again at the first, okay, search, okay, for when you are going to search for the first time. If this occurs for the first time, this L will be 0, and then you just compute, right, middle, okay, minus 1, like this, and then of course you are searching for x again, right, as you can see there, okay, and that should be all right. I hope you are actually getting the point. So if that element is greater than, okay, first we check if it's not, okay, that's for the first search, okay, let's just assume that we are searching for the first time. If it's not the case, then that means the element, okay, is less than that element which is at the middle. That means it's to the sub, okay, left sub array. That's why we are actually searching in the same array, but the in, okay, this, let's just say the boundary, okay, are changing now. So that means you're actually going to search to the left sub array now. That's why we divide, okay, the middle, we shift, because remember that this middle is the element to the middle and it doesn't match that value. That's why we move 1 to the index, okay, to the left, right. That means you're actually going to start from 0 now to the that middle index minus 1, because that middle element doesn't target, okay, does not, okay, match that value, right? So that's how it actually works. Okay, it works. So else what? Else you just do, okay, we just return simply. Else we just return what? The binary search, okay, for the right now. That's the binary search, okay, for the right one, okay, to the right side, because this errors, remember, is if the element is greater instead, okay, you just return like this, okay. That means if the element is, if this middle element is instead less than this x, that means the element should be, okay, maybe, because the element may not even, okay, be in the array. All right, so and in that case we should return minus 1, okay, out of this else, okay, we just return minus 1, and that should be okay, right? So this is it, right? It's pretty much simple, okay, just understand it like this. Again, what happens is that, okay, this, we are going to stop when, see the condition, we are going to stop returning, searching and so on till when this condition fails, okay. That's the base of criteria, okay. This, when this condition is going to fail, then we are going to stop this, okay, the search. Now remember this, okay, let's go ahead and execute this our code. Again, the recursion, okay, is very important, as we are going to, okay, talk about the time complexity, we are going to understand why we need recursion instead of iterative method, as the time complexity of the iterative method is large as compared to the recursion one time complexity. So let's go ahead to declare our array like this, and then just give some elements 2 3 and then 4, right? 10 and maybe let's just say 40 like this. That should be okay. And then let me just declare an integer n to be the size that we are going to actually assign to the size of array. So it's going to take the size of array, and then divide it by the size of actually this array of 0. Normally should be just return the size of the array. If you ask me why am I doing it this way, then we should definitely try to understand. Let's go ahead. That is it. But this, of course, you can even you can just put the size if you don't want to complicate it like this, but this is more suitable and memory management. So like this we have let us take 10 as our target value, and then in our result let's just return that binary search. Binary search to what? That takes what? Our array, remember, and then we start from 0, and then the size of the array minus 1, and then the element is x. Alright, so we're going to say that what? Let me just say something like this: result. Result. If result equals to minus 1, remember this one is actually the ternary operator. If it's like this, then you just do what? If it's equal to minus 1, then just print search error. That means the value doesn't exist. Search error like this. If not, then what are you going to say? Just print the index like this. Index is that is the index of the search element, because that's what we are looking for. The position. So index is %d, %d. Let's just go to new line, and then of course just print the result like this. This one is actually the ternary operator. So like this it should be okay. Alright, now this is it. Remember the ternary operator. So now let's just put our return for the main to actually say everything was done properly. If it returns 0, so let's go ahead and compile this our code and see if it works as expected. Right? As you can see there, we have an error, of course. So we have here array int. How did we declare it here? Of course, it's an integer. Sorry, here we have this like this. Normally, sorry for that. This one should be the array. So let's go ahead and save that and start it back like this. Should be okay. Right? What's happening? Binary search return. Binary search of what? What's actually happening? Declare int binary search what? Few arguments. What we miss here? Sorry for that. Here there's actually h. Alright, sorry for that, guys. Okay, here this h. Okay, so normally everything should work now. Okay, like this. Okay, and then just compile it. Okay, you see that the index is actually at position. Okay, position 3 is 10. So this, okay, how it works. All right, so we are done, okay, with the a recursive method. Okay, the recursion that is called itself back, but now with the half array. Half array, why? Because we are actually limiting this, okay, to right with this low and high. Okay, so hence we are done, okay, with the iterate or recursive and aggressive methods of binary search. We are then move forward and talk, okay, about more, okay, algorithms, okay, then where we can apply binary search, okay, iterative method, and later on we're also going to talk about time complexity, space complexity, the big O notation, and so on. Right, definitely you should not miss that, guys. See you then. Bye.